All right, this next section is about partial fraction decomposition. It's basically a calculus application of solving systems of equations. What we're trying to do is we're given this fraction and we're trying to break it apart as if it were two fractions that need to be combined. So we start off by recognizing that this is not a linear term, so it's not just x plus 7. This has to be a higher order, so higher exponent. So it's going to be x squared or x cubed or something that can be factored. So if it can be factored, let's try and factor it. Change my color to, let's go with pink. I haven't used pink in a while. So we're going to try and factor this bad boy. We need factors of negative 14 and add to 5. So that's going to factor to x plus 7, x minus 2. Okay? So we should all recognize that this is the factored form of this denominator. So our goal here is to take this fraction and break it into two separate fractions. Each one of our fractions, and I say two because we have two factors here, and each one of these two fractions is going to have a factor as its denominator. So we're split into two fractions. One fraction is going to have the denominator of x plus 7, and the other denominator is going to have the of x minus 2. So our goal is to split into two fractions. Well, now we got to figure out what we want for the numerator. Well, we don't know what our numerator is, so I'm just going to put in some variable a, some variable b. Again, this is a skill that you would use in calculus. A lot for integration, so a long way away, but you should know how to do it once you leave pre-calc. So we're trying to find these values for a and b. So if we were to combine these fractions, we will get back to this fraction right here. So let's do that as if we were trying to combine them. So if we were to combine these two fractions, we need a common denominator. So the common denominator between x plus 7 and x minus 2 is x plus 7 x minus 2. So I'm going to multiply the top and bottom by this fraction by x minus 2. And I'm going to multiply the other fraction by the other denominator. So now we're left with ax minus 2a, because I just distributed this a to both these terms. So we got ax minus 2a plus b times x, bx, plus 7 times b, which is 7b, over our new denominators. Now since we have a common denominator, now we're allowed to combine these numerators. So I combined our like terms, so we have ax plus bx, and then negative 2a plus 7b over our denominator, and it's equal to this denominator, the thing we're trying to decompose or break apart. So you'll see over here that these two are equal to each other. So if we were to multiply both sides by x plus 7, x minus 2, they would cancel out. So now we're left with, I rearranged these a little bit so I have more room. So now we're left with 4 equals ax plus bx minus 2a plus 7b. These coefficients represent the x term of this side of the equation, and these two numbers represent the constants of this side of the equation. So you'll notice that ax plus bx represents the variable, which there is no variable over here. So that means 0x equals ax plus bx. And 4 is equal to negative 2a plus 7b. Okay? So on this side of the equation we have 0x plus 4, 0x plus 4, and then on this side we have a plus bx, ax plus bx, minus 2a plus 7b. So these represents the constant, and these represents the variable. So we know that 0 equals a plus b. We know that 4 is equal to negative 2a plus 7b. Well, here we have a system of equations. This is a system of equations right here. So we're going to try and solve this system of equations. So once we find the a and b that satisfy this system, we're going to plug it back into this a and this b, and that's going to give us our decomposed fraction. After you solve this system of equations, I mean, you can use any method, solving by substitution, by elimination. You can try and graph these. You can even put them in matrices and get the solution that way. But any way you do it, you should be getting A to equal -4/9 and B to equal +4/9. So our decomposed fraction would be, I'm just going to plug them back into for A and B. So A was -4/9, so that's -4/9 over x plus 7, plus our B, which is 4/9, 4/9 over x minus 2. And this is our decomposed fraction of 4 over x squared plus 5x minus 14. And that there is our final answer. So, to sum up what we did, I first started by factoring this polynomial. So now we have our factors here. And I wanted to decompose this fraction. So we're having two fractions because we have two factors. So that means each factor has its own fraction with some constant. We don't know what that is yet. So to combine these fractions, we need a common denominator. So I multiply this fraction by x minus 2. And multiply this whole fraction by x plus 7. That led us down to over here, where I combine like terms and set up a fraction this way. So we have our ax plus bx minus 2a plus 7b equals 4. So this term, ax plus bx, represents the variables, which we have 0 of. So 0x equals ax plus bx. And negative 2a plus 7b represents the constants, which we have 4. So 4 equals negative 2a plus 7b. That gave us a system of equations, which we know how to solve based on this last chapter and all that good stuff. You can use substitution, elimination, matrices, what have you. But after you do that, you should get A to equal -4/9 and B to the 4/9. Plug it back in for A and B, and now we have a decomposed fraction.